Hey everyone, welcome to my Triple E, that is my electrical engineering expertise. And in this video series, we're going to talk about electrical and electronic circuits, where we will cover topics from the basic concepts in electrical circuits all the way to the analysis of AC circuits. And the goal of this video series is to provide you with a strong foundation in understanding and solving complex circuits. Throughout this course, I will place special emphasis on solving as many example problems at the end of each topic to help solidify those concepts that we talk about. So let's jump straight into this first video. In this video, we're going to talk about three basic concepts in electrical engineering. We're going to talk about circuit elements and electric circuits, then we're going to talk about SI units, and then we will talk about electrical charge, electrical current, and their relationship to each other. In electrical and computer engineering, we're interested in transferring electrical energy from one point to another point. And in order for us to do this, we need an interconnection of electrical components or circuit elements. Some common circuit elements that you're probably already familiar with are resistors, voltage and current sources like batteries, and capacitors and inductors. And these circuit elements alone are not very useful in the real world. However, when we interconnect these circuit elements and produce an electric circuit, it can be very useful and practical in the real world. So for example, we have a voltage source, we have two capacitors, an inductor, and a resistor. But these circuit elements alone are not very useful. However, when we interconnect these circuit elements, using wires particularly, this can become very useful. The second example is the same concept. We have a battery, we have a resistor, a light bulb, and a switch. Again, these circuit elements are not useful by themselves. However, when we interconnect these components, it can become very useful and practical in the real world. We now have a light that can be controlled using an on-off switch. When solving or designing electric circuits, we deal with measurable quantities. And our measurements must be communicated in a standard language so that all professionals, regardless of the country, can understand. And this language is called the International System of Units, or SI units. In this system, the SI unit system, there are base quantities, and then you have prefixes based on the power of 10 to relate smaller or larger units to the base unit. So in the figure on the left, we have the base unit for length, mass, time, electric current, thermodynamic temperature, luminous intensity, and charge. And then we have the base unit for each of these. And we can relate this base unit to smaller or larger units based on the prefixes. So for example, if we have 600 million millimeters, that is equivalent to 600,000 meters, which is also equal to 600 kilometers. Now again, I will post another video of working problems and solving problems and converting back and forth from smaller and larger units to the base unit. So look out for that video. The first basic concept we will talk about is electric charge. The formal definition for charge is that it is an electrical property of the atomic particles of which matter consists, measured in coulombs. So what this definition says is that all things, or all matter, is made up of atoms. And atoms have protons, neutrons, and electrons. Of those three, protons and electrons are charged particles. And these protons and electrons have the same charge but the different sign. So for example, the charge of an electron is negative 1.602 times 10 to the negative 19th coulombs, and the charge of a proton is 1.6 or positive 1.602 times 10 to the negative 19th coulombs. So 1 coulomb of charge is equal to 6.24 times 10 to the 18th electrons. So this shows that it takes a lot of electrons just to produce 1 coulomb of charge. And to show how we got this number, we have 1 coulomb of charge, And we know that in one electron, there's 1.602 times 10 to the negative 19th coulombs. If you divide this out, you will get 6.24 times 10 to the 18th electrons. So it takes a lot of electrons to produce 1 coulomb of charge. And an important law about charge is the law of conservation of charge, which states that charge can neither be created nor destroyed, only transferred. So we can move charge. And this brings us to our second basic concept, which is electric current. Formal definition for electric current is that it is the time rate of change of charge measured in amperes. So 1 amp is equal to 1 coulomb per second, where an amp is also the same thing as a coulomb per second. So to understand electric current, we're going to look at a copper wire. The reason that copper is such a good conductor is that copper atoms have free electrons that can be moved. And these electrons, again, are charged particles. So in these copper wires, these electrons are moving in a random motion. And because of this random motion, the net current is equal to 0. However, if we take this same copper wire with these electrons and we attach a voltage source across it, now we have these charged particles all moving in the same direction, and that is current. The time rate of change of charge. So these charges are all moving in the same direction through the copper wire. Now to quantify this, if we take a single point on this wire, which we'll say right here, how many electrons cross this point per second? That is the time rate of change of charge. So the more electrons you have crossing a particular point per second, the greater the current. The less electrons you have crossing a point per second, the less current you have. And so this is mathematically represented by this formula. I is equal to dq dt, or the time derivative of charge. What if we know the current and we want to find the charge? How can we manipulate this formula? We can take the integral of both sides. When we do that, the integral and the derivative on this side cancel. So we're left with the integral I is equal to Q. Or if you just write that a different way, we have the Q, or the charge, is equal to the integral of the current, which is the integral of I dt. So these two equations, I equal dq dt, and Q is equal to the integral of I dt, or the relationship, or the mathematically describe the relationship between charge and electric current. I will also be posting a video on how to find charge, or how to find the number of electrons and current in another video, so also look out for that video as well. And then I'll also, in the next topic that we discuss, we're going to talk about electron current versus conventional current, and then we'll talk about voltage, power, and energy.